about images. Now, some interesting things here we're going to talk about. You should see some parallel between what we're talking about with images and what we talked about audio. All right? Because in both cases, what we're doing is we're taking something and digitizing it. That is, we're converting it to a set of numbers, right? And there's some inherent issues with that, and many of them will be very similar when we talk about audio or when we talk about images. For example, the more numbers that we store, the bigger the file is going to be, the better quality it's going to be. All right? The more numbers we store about a particular piece of it, whether you're talking about a single audio sample or a single pixel, the more numbers we store about that, the more information we can have and the better quality it's going to be, and again, a bigger file size. All right, let's start out by talking about two different kinds of images. All right? And I'm going to talk about this for a minute, then we'll actually demonstrate on the computer. These two types of images are called vector images and bitmap images. Now, by bitmap, I don't mean just the .bmp file in Windows. So it's not just the BMP. But actually, JPEGs are also bitmaps as well. All right? Sometimes these images are called raster images. All right? What's the difference between the two? The difference between the two is the manner in which the information about the image is stored. And that difference yields many implications. With a vector image, mathematical expressions are stored. Let's talk about drawing a circle. Let's talk about drawing a circle that is smack dab in the center of my screen. All right? And if you remember from math, the old Cartesian plane, if you had algebra or whatever. Let's say we have a circle with a radius of 1 in the middle of the screen. Now, this is the x and y coordinates. The equation for that circle is this. X squared plus y squared equals 1. The general form of this is x minus k plus y minus h equals r squared. Aren't you glad there's no exams in this course? All right? What does that mean? That's a mathematical expression. So, let's forget about the h and the k, because that kind of clouds the issue. X squared plus y squared equals radius squared. So if I want to make it a circle with a radius of 2, what does the equation become? X squared plus y squared equals 4, and so on. And I could graph that. And that will also be a perfect circle with a radius of 2, and so on. So if I have a shape, if I have a circle, and I describe it by some mathematical means, I can enlarge that circle, and I can move that circle simply by changing some of the mathematical elements in it. That's sort of the bottom line. I promise this is all the algebra or geometry we're going to talk about today. The point is if I describe it mathematically, I can make changes to it and get another perfect circle just located in a different spot, or maybe with a different whatever, and it'll be perfect. That is the notion of vector graphics. With vector graphics, shapes are stored as mathematical expressions. Now, let's look at what are called raster graphics. And I'm going to approximate this. Let's say I have an 8 by 8 grid. Alright? And let's make it real easy and say I only have two colors to worry about, black and white. And we'll represent 1 will mean black, 0 will mean white. So 1 equals black, 0 equals white. Now keep in mind, this is meant to be like a highly magnified version of the screen. Alright? This is meant to be like we're zooming in on the pixels of the screen. So we have this 8 by 8 grid, and we're going to draw a circle in it. Our circle would look probably something like this. Okay, I think I messed up something. Will look something like that. Now, it looks jagged because, you know, we're doing the zoom in on it. If we were far enough away from this, or if we drew these real small, that would look like a continuous circle. All right? Now, we said with a vector graphic that we're going to store the mathematical expression. All right? With a bitmap or a raster graphic, what we're going to do is we're going to store a series of numbers for each of our little squares in the grid that represent what color they are. Now, for this particular very simplistic image format, we have 8 by 8, so that will be 64 numbers. All right? And the numbers will either be a 0 or a 1, depending on whether it's white or black. So, maybe the way I would store this would be 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, and so on for the rest of it. Now, what's the difference with this? The difference with this is if I had, let's draw maybe a circle on here. Remember the manner in which that's stored. If I have a circle that's this big, and I draw it as a bitmap, if I make it bigger, what's going to happen to it? If I made that twice as big, yes? Exactly. If I make this image bigger, I'm going to see the jagged edges of it. All right? Kind of like a photograph in a newspaper, right? A photograph in a newspaper is a bunch of dots. If you look at it far away. If you look at it real close, you can see the dots. Or if you're going to blow it up real big, you can see the dots. So if I take this, and if the pixels were small, and I drew what looked like a good circle for me, I'm still storing it in that sort of jaggedy way, right? Which means if I make this twice as big, my circle is going to kind of not really look like a circle, but look like a circle with jagged edges. And so on. Alright? Maybe not that bad, but you get the idea. Let's go into Flash, which uses vector graphics, and Paint, which uses raster graphics, and see the difference. So, first thing we're going to do is I'm going to go into Flash and draw a circle. And if you remember, we've already sort of seen this, right? Because we made the ball come towards us and go away, and it didn't look jaggy when it came towards us or away. So we've already sort of seen an example of this. So let's go in. And let's draw a circle, or as close as we can to a circle. All right, let's go in. Let's go and draw a circle. We'll make it a little one. All right. Let's go make it a symbol. And let's go and make a motion tween for this. And let's go, I'm going to slow this way down. I'll make it 1 frame per second instead of 24 so it doesn't fly. I'll then go into this frame and I'll make the size of this. I'll change the height and width from being 30.5, 30.5, 30.5, I'll make it 200. All right. So, notice as we resize it, notice that we still have a circle. All right. We still have a circle as we resize it. Why? Because it didn't store it as a bitmap. It didn't store it as a series of numbers for each position in my little grid there. It stored it as some sort of mathematical expression. So if I say, hey, I no longer want it to be this big, I want it to be this big, it just plugs different numbers in that mathematical expression and gets a bigger picture, or gets a bigger shape. Let's compare that to doing this in Paint. So let's go into Paint and create a raster drawing of the same circle, or similar circle. All right, there's a circle. And I'm going to go and save this. On the desktop. And I'm going to store it as a JPEG. Save it as a circle. Now, if I go in and one thing we could do, I suppose, is zoom. Zoom in a bunch of times. All right. At that side, we can really see that what looked like a circle before really is sort of a jagged, edged thing. Why is that? Well, because there's not enough information to fill in. All right. If I draw my circle, let's go back to 100%. If I draw my circle, even if I look real close to it, I can see a little bit of the jagged. But from that distance, it looks like a reasonable circle. When I go and make this bigger, though, all right, it looks like a good circle because there's enough information in there to make it look like a circle. There's enough dots and to make it look like a circle. As I make it bigger, there's not enough information in that circle to make it continue to look like a circle. Therefore, Paint guesses at what to do. And it guesses in the way of making it jagged edges. That's why, again, to go the other way, I can make it smaller and it still looks like a circle. Because it's okay getting rid of information. It's only when I go and zoom out that at a certain point it starts to look jagged. Because there simply isn't enough information there. That's why you can take images and make them smaller, and you'll see a reasonably good quality, but if you make them bigger, you're going to see worse quality. For example, if we were to go in and open one of our images in Paint, a JPEG image, I just added open to something. I didn't actually open something. These newfangled computers. Alright, if I go here and let's say I open a jellyfish. Alright, there it looks like a jellyfish. If I were to go and zoom in enough times, I can actually see it on my monitor already. But you should be able to see what looked like a smooth edge of the jellyfish is actually a jagged edge. So making an image small is okay. Making an image bigger, you're going to run into issues. That's why it's always good, in my mind, to take the picture at the highest resolution you possibly can, and then go and resize it, keeping the original. So don't go and save over top of your original image. Take them. Stash the originals over there and then make a copy of them and do your playing around with that, because you can always make it smaller without any problem. But if I were to say make it to be a 400 by 400 pixel picture and decide, oops, I want it to be 600 by 600, if I didn't have the original, I wouldn't be able to expand the smaller one into that. Next time we'll talk more about specific file types. We talked about raster and bitmap images, or raster/bitmap images and vector images today. We'll talk about specific file types for raster images next time.